practice that sheet I gave in class. Hopefully you'll take a look at it. It's a beautiful day. It's Saturday. It's about 9:30. This should be up in about half an hour. Go ahead out, enjoy the day, get some vitamin D. When you have nothing better to do this weekend, come back, take out that sheet, take out your work, and then check your answers. Okay, but I'm gonna start now. All right, so first set of questions saying, here's a triangle, right? With side lengths 4, 7, and 10. And just so that you know, this is the smallest side, this is the medium side, and this is the large side. So they're saying, hey, we built five supposedly scaled copy, and they want us to know if any of them are actually were done correctly. So let's take a look at this first one here. So this one is 8, this one is 11, and this is 14. How did I know where to put the sides? Well, because they're gonna follow the same pattern, right? The small side out of the 3 measurements, the small one will go here, the medium one will go here, and the large one will go here. This one's kind of obvious, right? Because if you look at, and this is that triangle Z that they made. So how did the 4, so we can just visually check here. The 4 times 2 became 8, the 7, sorry, I take it back. I take everything back. 4, it was a scale factor of 2, and then 7, right, if you use the same scale factor, which is what you're supposed to do, 7 times 2, 11? It's not. It's 10 times 2, 14? Obviously, it's not as well. So is triangle Z here, this version, letter A, a scaled copy of the original triangle M? It's not, because as you can tell, 4 was multiplied by 2, but the other 2, a different scale factor was used. Okay, so definitely not. So you can just say no. This is a no. Okay. Let's look at the second triangle. So it looks like it's a smaller one. So just bear my artistic talent. 2, 3.5, and again the medium one goes on the right side, and at the bottom is a 5. Well, this one looks okay. Now look at this way. Let's find a scale factor. Let's get used to that. So the scale factor. How do we find a scale factor? First, let's determine if this was an enlargement. Did it get bigger or did it get smaller? Well, it got smaller, right? So it was a reduction, right? So it's smaller, reduction. And to find the scale factor, how? What did I multiply 4 by to get 2? What did I multiply 7 to get 3.5? What did I multiply 10 to get 5? Well, let's pick 2 corresponding sides now. Let's pick 2 easy numbers. Let's pick the 2 and the 4, right? So using the 2 and the 4, right, corresponding side, and let me write, remember, it's small over big. And we're between 2 and 4, the small one is 2, the big one is 4. We can simplify to a half. So either you leave it as a half, or if you want to change it to a decimal, it's up to you. So if you take a calculator, or you can just do it in your head, and you take 4 times a half, multiply each of these sides. 4 times a half, is that 2? Yes. 7 times a half, is that 3.5? Yes. And then 10 times a half is 5. So I'm going to take advantage. So as to be a reduction, we multiply by a factor of a half. Now, what if I told you, hey, when we get here to the small triangle, let's go back. Let's go back. What would be the scale factor that I would have to use? Well, if going one way was a half, right, and going back to the original, well, what is the reciprocal of 2? Reciprocal of 2, so let me write that. The reciprocal of a half is 2. And let's see if that works. Look, if I take 5 and multiply by 2, is that 10? It's 3.5 times 2, 7. Is 2 times 2, 4. So to get bigger, I multiply by 2, and to get smaller, I multiply by half. Okay, so there's a special relationship between these two. And the word is the reciprocals, right? 3. So now they said, hey, what about 6, 10, and 15? Well, I got fooled on this one. Well, let's find the scale factor. Also, if you go from this triangle to this triangle, we can see that's an enlargement. It got bigger, not by much, but it still got bigger. So let me find a scale factor. And I think that's the safest way. Scale factor. When it's an enlargement, it's big over small. Pick two corresponding sides. I don't care which one you pick. Pick this one. Let's pick 15 and 10. Right? Let's be different. 15 and 10. So if you pick 15 and 10, right, the two corresponding sides, because we're talking about the base of this triangle and the base of this triangle, the scale factor, right, it's going to be 15, the bigger number, over 10. 15 over 10 is simply 3 over 2. I suggest leaving that as a fraction because we can, sometimes the question will ask for the reciprocal. It's much easier to find it. Or, as of for now, we can leave it as 1.5. So it makes sense, right? Because if it's an enlargement, the scale factor has to be greater than 1. So then this number is definitely greater than 1. It's 1.5. So it did get bigger, look, by a little bit. So if you take a calculator, you multiply 4, if you go 4 times 1.5, it is 6. If you go 10 times 1.5, it is 15. And then if you multiply 7 times 1.5, is it 10? No, it's not. So it fails here. Okay? Because it's actually 10.5. All right? So is this triangle here, this one that I'm shading in blue, is that a scale factor of that one? It is not. So this one fails. We have another triangle. It's look bigger, right? So let's pretend it's bigger. That's a 10. That's a 17.5, and that's a 25. Yikes! All right, so let's find a scale factor. All right, you have to find a scale factor. All right, so I'm gonna pick two corresponding sides. Let's keep it simple. The easiest numbers, the 10 and the 4. So first of all, reduction or enlargement? Enlargement. It got bigger. Right, so to find a scale factor, what did I multiply 4 by to get to 10? What did I multiply 7 to get to 17.5? What did I multiply 10 to get 25? So no need to guess. So between 4 and 10, sorry, first of all, it's big or small. So the scale factor that was used, well, between 4 and 10, the big number is 10, the small number is 4, and that simplifies to 5 over 2, or 2.5. So take a moment. Multiply 4 times 2.5. Is that 10? Yes, it is. Let's do the easy one. 10. 10 times 2.5. Is it 25? And then multiply 7 times 2.5. That's 14. 14 and 3.5. 17.5. Oh, look at that. And 7 times 2.5 is 17.5. So where each of these side lengths multiplied by the same scale factor? Yes, everybody here was multiplied by 2.5, or as a fraction, 5 over 2. So going that way. Okay, so this one, hey, it's a check. 5, 8, and 11. That doesn't look good. So this is the 5, this is the 8, and this is the 11. Yuck. Well, I might be wrong. So again, we can tell that's enlargement got bigger, right? Not by much again. So the scale factor, let's pick 4 and 5, right? These two corresponding sides. It is an enlargement, so we're going to use big over small. And between the corresponding sides 4 and 5, the big number is 5 and the small number is 4. So the scale factor is 5 over 4. I'm going to leave it as a fraction. Okay, you can change that to a decimal if you like. You don't have to. So let's multiply. So if I take 4 and multiply it by 5 over 4, look what happens. Let me put this over 1. 4 times 5 is 20, right? At the top, and 1 times 4 is 4. And if you simplify 20 over 4, you get 5. So 4 times the scale factor 5, does it give you 5? So this number is okay. Let's do the 7. Let's take 7 and multiply that by 5 over 4. Let's see if I get 8, right? Because that's what I'm supposed to get. So 7. So on the top, 35. At the bottom is 4. That is definitely 8 point something, right? It's, if it was 32 divided by 4 would be 8, but this is a little bit more than 32. So it's 8 and change. So is 7 times 5 over 4 8? It is not. So it fails here. That fails. And it's 10 times 5 over 4. So 10 oops, we'll take a 10 times the scale factor that we found, 5 over 4. 10 times 5 is 50 over 4. Absolutely not, because 50 over 4, it's definitely what? Well, 12 and change, right? So it fails there as well. So 10 times 5 over 4 is definitely not equal to 11. So it fails. So this one was not correct. Yeah, a little bit of work, I agree, but here, this one is might create some confusion. You have a figure W is a scale copy of figure G. So let's do figure G, and let's keep it a triangle. So there was a triangle. They called it G. And somebody made a scale copy. Now notice that it doesn't say it got bigger. It doesn't tell me what the scale copy. So I have no idea what this scale copy is. Could be bigger, right? If it's an enlargement. So I don't know. And it could be what? It could be smaller if it was a reduction. I don't know. But I know it's a scale copy. So it's either could be this one or it could be this one. Just keep that in mind for a second. So look at the first statement. Figure W, whether it's this one or this one, right, whether it was an enlargement or a reduction, has the same number size of figure G. Well, if it's a scale copy, that is a true statement. 3 sides, 3 sides, 3 sides, same shape even. So this one is a true statement. Now, B says figure W is larger than G. I don't know that. They're telling me that this, I don't know. Are we talking about this guy? Change colors. Are we talking about this guy or are we talking about this guy? I don't know which the scaled copy is. It just says, hey, there's a figure W. I don't know if it's a small one or a large one. So figure W is larger than G. It could be, but thing says select all statements that must be true. It could be if it was an enlargement, right? If it's not, then it's not true. Because what if we were talking about this one? Because I don't know which of these two triangles we're talking about, the larger one or the small one, I'm not going to say that's true. But it could be. It could be true if they're talking about this one. Okay? Yeah. Figure W has the same angle measurements of figure G. That's true. This angle here, and this angle here, and this angle here, they're all the same. This angle on the top, this angle on the top, and this angle on the top here is the same. And then this angle, and this, they're all the same. So that one is okay. The scale factor from W to G is less than 1. Listen. From W to G. If I'm going from here to here, that's true. It went from big to small, so the scale factor is less than 1. But what if I went from this one, the small triangle? I went from this small triangle to this one. It's an enlargement, so the scale factor is going to be greater than 1. So is this statement true as it is? No, it's not true. Because I don't know which of the scale copies they're talking about. Okay, but if you're talking about going from the big one to the small one, then yes. The scale factor from W to G is the same as a scale factor from figure G to W. You know what? Let me just redraw this one so that you understand. So here is figure W, small one. Here is a figure W. This is a scaled copy, by the way. And here, let's just assume that this one, the medium one, is the original. So here is the original one, which they are calling G. And let's say this was, I am completely making this up, okay? 4, 4, 6. This was a 2, 2, 3. And this was a 8, 8, 12. Okay? So hopefully you can see that, hey, when it got bigger, when it's an enlargement, right? All the sides got multiplied by 2, right? So it was a scale factor of times 2. When it got reduced, what's the scale factor? The scale factor is half, which is the reciprocal of this. Maybe, you know what, I'm going to do this. I'll take this and move it a little bit over here. And then I'm going to draw the small one over here. Times a half. And this is the 2, 2, 3. So enlargement was times a half. and then a reduction was a half. So they're saying from figure W to figure G, the other way. Well, it doesn't matter. Actually, let's do it properly. So let me erase this. Let me erase that. Hang on. Let me show you what they mean. So here are the scaled copies. This is a 2, 2, and 3. I made it up, right? So here's my 3 shapes. So they're saying if I go from this guy to here, we know it's a reduction, and we just talked about the scale factor is a half. If I go from here to here, I think everybody can see, hopefully, that it's a enlargement, right? So the scale factor obviously is greater than 1, so it's times 2. What they're saying is that this scale factor and this scale factor is the same. That's not actually, no, that's not what they're saying. Well, first of all, I'm going to take advantage of the example that I'm writing. These are not the same scale factors because one is a reduction, so the scale factor is less than 1, which is a half, and the other one is an enlargement, which says that which means that the scale factor is greater than 1, which is 2. But what they're really saying, the scale factor from W, so let me erase this guy, right? They said the scale factor from W to G, in this case is a reduction, is a half. And then if you go back from G to W, it's also a half. And we know that's not true. Okay, going this way, a reduction is a half, but going back, enlargement, it's not a half. What's the reciprocal of a half? The reciprocal of a half is 2. Okay, I just made a mess out of that question. Hopefully you'll figure it out. Okay, triangle PQR is a scale copy. So they're telling you it's a scale copy. So if it's a scale copy, we know a couple of things. It's the same shape, yes, it matches. They're both triangles. We know that these guys here, this angle and this angle measure the same. This angle and this angle measures the same. And then we have this angle over here at the bottom measures the same as this one. All right, so that's true. So angle J, and sorry, I'll highlight angle J and angle P are the same. Yes. Angle K, I'm going to change to blue. Angle K is here. Is the same as angle R? Absolutely not. One scale factor in this situation is 3 over 2. Well, which way would it be 3 over 2? Clear annotations. Well, 3 over 2 is greater than 1, right? So if it's greater than 1, it has to be talking about enlargement. So they're definitely talking about going this way. Is the scale factor going from the small one to the big one 3 over 2? Well, let's check it out. Scale factor, big over small, right? And let's pick 6 and 9. It'll be 9 over 6. And if we simplify, divide by 3, top and bottom, we get 3 over 2. Yes. So look, one of the scale factors is 3 over 2. Check. The other scale factor, so if we are going enlargement, the scale factor is 3 over 2. If we're going for reduction and going back to the original, do we even have to do any work? No. We can use a reciprocal. What's the reciprocal of 3 over 2? 2 over 3. That's also check. The ratio of J to K, of JK, so the ratio of JK right here, let me highlight, that's JK, to JL, right? 4 to 6, right? This is JK, the line JK, and the line segment JL. The ratio of those two is equal to the ratio of PQ over who? Over PR, 9. Are they the same? Well, first of all, let me show you that. Did they use corresponding sides, right? The ratio, let me highlight 4 with purple, and then I'm going to highlight 6 with purple. So notice that side to side, they are the corresponding sides. And then 6, JL is this guy. And right next to 6 on the right side, on the other ratio, they used 9. So that was done correctly. So are they equal to each other? How can we check? You can do your 5th grade butterfly. 4 times 9 is 36. 6 times 6 is 36. So we can see that the ratio are the same. The other way to do it is to simplify both ratios. 4 over 6 simplified becomes 2/3. What's 6 over 9 simplified? Divide 6 by 3, we get 2. Divide 9 by 3, we also get 3. So is 2/3 equal to 2/3? Yes. So the last one is a true statement. Where am I? Fix it. You want to create a scale copy. Yona drew EFGH. So this is the original. Okay. Oh no. Yeah, so this is the original. Let me write original on top. Original. Scale copy. And they asked us to fix it. How would you explain to Yona that EFGH is not a scale copy? Well, let's see if the scale copy. Look at this. Right? Let's look at that. And then let's look at 6 over 4. 6 to 4. Well, 2 to go to 1. How did the 2? Times a half, right? Becomes 1. 6 times a half. Is it 4? It's not. So she obviously didn't use the same scale factor. And then if you want to check with 4, is 4 times a half 3? Obviously not. So this is incorrect. You can say, Yona, you didn't apply the same scale factor. Okay, you can tell it. I found the scale factor. I picked these two sides, right, to find the scale factor. I know it's a reduction. So I picked 2 and 1, and the reduction is small over big, and I found that the scale factor was, well, small over big, it's half. And then you applied it, and it worked for this one. 2 times a half is 1, but then it fails everywhere else. It's 6 times a half 4, it's 4 times a half 3, it is not. So you should have used this scale factor with all the other side lengths as well. What advice would you give to Yuna you can produce so that she can produce a scale copy? Well, in this case, we can tell that she should have, I guess just like I said, use the same scale. I don't even know how she got these numbers, but from here, multiply by half, and then take each of the sides and make sure to multiply that by half, multiply that by half, multiply that by half, and make sure that all of them are multiplied by the same scale factor. Hopefully that helps her. JKLM is a scale copy of ABC. Okay, so again, we're going this way, right? Label each missing length so that the sides are, okay, proportional to the side, right? So let's, find the scale factor first, because I need to know what this is, I need to know what this is, and I need to know what that is, right? But I don't know what the scale factor is. I know it's a reduction, right? We can clearly see it's a reduction. So scale factor. I'm going to use this side and this side, small over big, and we get 0.5 over 2. Okay. Oops, sorry. And put that in your calculator, you're going to get a quarter, right? How would I do it? This is, I'll make this at least, so 0.5 can be rewritten. I'm not going to complicate life here. Right. 0.5 over 2. 2 ways so that you can get rid of that decimal. You can multiply the top one by both top and bottom by 10. If you multiply top and bottom by 10, I'm going to move that decimal one space to the right? Or that's a shortcut. So, but if you take 0.5 and multiply by 10, look what happens. It becomes 5. And your decimal is gone. 0. So think about 50 cents. Multiply that by 10. What do I have now? You get 5. And then with fractions, right, to create equivalent fractions, if you multiply the top by 10, I have to multiply the bottom by 10, and I get 20. I can simplify 5 over 20 to 1/4. That's the scale factor. could have actually divided 0.5 divided by 2 if you want to go through the process. Right, I don't want to deal with whole number, I think with decimals. So again, I'm going to move to decimal as you learn 1 unit to the right, which is the same thing as what I did here, which is multiply both numbers by 10. If I multiply both numbers by 10, now I have a 20 here, and 0.5 times 10 is 5. And that's right, instead of just moving it there, there's a reason why we move it there. So now 5 divided by 20, it goes to the same process. 20 goes into 5, does not. Add a decimal, can 20 go into 50? Yes, it can. 2 times, which is 40. Subtract, let's bring another one down, and that makes it 20 goes to 105 times. 0.25, and again, that is 1 over 4. I don't know which way is easier, but I would have much rather, well, anyways, the bottom line is that whichever procedure you take, 0.5 or 2 is the same thing as a fourth. Okay. So now that you know this, now you know the scale factor. So everything here in the original one was multiplied by a fourth. So 2 times a fourth is 0.5. Think about $2. If I come and take 1/4 from you, so think about this is $2, right? This is 0, 50 cents, $1, $1.50, and then go around is $2, right? And I took a quarter from you. How much did I take? I took 50 cents. Make sense? 4. Now let's multiply 4 times a quarter. Right? If you have $4 and I took 1/4 of what you had, how much would I take? Well, I would take 1. Sorry. So 4 times 1/4 is 1. 4 times 1/4 is 1 as well. What about 6? 6. What's 1/4 of 6? Well, 6 times 1 is 6 at the bottom. If you want to put a number there, 1 times 4 is 4. You get 6 over 4, which is 3 over 2. 3 over 2 is equal to 1.5. So for this one, because it's side measurement, I think it's better if you use decimal. So this is 1/5. So the task here was A, find the scale factor first. You have a calculator, okay? You could have just entered 0.5 over 2, get 1/4, right? And then multiply all these side lengths times 1/4 times 1/4 times 1/4 to get our result here. Okay, I know, long video. Using scale factor 2. The scale factor 2 is the measure of twice as much. So figure C has an area of 28. Okay, that's the original. Okay, so this is the original. Right, so remember what we did in class. So it's going to help for us to write original. They're not asking us for the perimeter, but I'm just going to write it there anyway. And this is the area. So remember what we did. But this is the original. So the original, which is figure C, has an area of 28. And the perimeter, I'm going to go and do the perimeter. Okay? So if you took your dog for a walk around this park, you would go 1, 2, 3, I can't see, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. He would walk 30 steps and 30 units. Everybody okay with this? So they made a scaled copy. So somebody made, I'll do it over here, a bigger version. Right? Twice as big. So, scale factor of 2 without drawing it. Okay, I don't want to draw this. Right? It's nice today, I want to go outside, so I don't want to draw it. What would you do? Well, to find the perimeter, well, if it's a scale factor of 2, that means that this 2 here, we talk about perimeter, is now 1, 2, 3, 4. This height right here, which was 1, 2, 3, 4, 5, 6, 7, is now 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It doubled. So as far as you taking a walk with your dog around the shape, distance doubled. So that's easy. 30 times 2, that'd be 60. I'm going to add one more here. scale factor of 3. Now let's say somebody made a bigger park, 3 times as big. So instead of 2 here, multiply that by 3, that would be 6 going this way. Instead of 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Instead of 7 here, times 3 would be 21. So you can see that everything got tripled from the original, right? Everything got tripled from the original just to find the perimeter. I know we're not, the question's not talking about that, but I'm discussing it anyways. So if it got triple, so now the original was 30, so if it's triple, 30 times 3 is 90. Yeah, but that's the perimeter. What about the area? Okay, I don't want to draw it. You don't want to count squares. This is a composite figure. We can break it into rectangles. Find the area of this guy, then find the area of this guy, find the area of this guy, and add them up. We're not going to do that. So, what if it's this doubled? What if the area, so again, it was 2, now it's 4, this was 7, now it's 14. We double everything, right? Everything is double, right? And we now have to count the number of square units inside. 1, 2, 3, 4. And keep counting. I don't want to count. So what is that pattern that we found in class? Okay, so, and I'll write it over here to find the area. Find area of a scaled copy, right? We can simply take the scale factor, take that to the second power, and then times the original area, right? So that's the little pattern that we found. So the second one, what's the scale factor? 2. Take 2 to the second power, and then we multiply by the original area. In here right now, in C, here, they're 28. The area is 28 square units, so we're going to multiply it by 28. So if you make everything bigger by 2, the side lengths, the area is going to change. But how is it going to be affected? Well, take the scale factor, raise it to second power, and multiply it by 28. So now 2 to the second power is 4, and 28 times 4, 2, carry 3. 4 times 2 is 8. It's 112. So now inside, there is did I multiply that right? Yeah, 112. What about scale factor of 3? What if we talk about the big? I just made this shape 3 times as bigger, and we noticed that the perimeter was 90. Well, to find the area, the space inside, we're going to take the scale factor, raise it to the second power, and then multiply by the original area. 28. 3 to the second power is 9, and what's 28 times 9? 72, 18, 252 square units. And this one as well. Okay, so this is what you have to do. Okay. Are we done? No? Yes? Please? No? Scale factor half. Oh, I didn't have to draw. Oh my God. Okay. So, and they don't give us paper or room to draw. Everything is going to be a half. But this, they actually want me to draw. Okay. So a half. So let's do that. So a half would be half a square. This goes diagonal. So this goes diagonally. Think about it. It goes diagonally through two squares and another 2. So I'm going to cut it in half. It'd just be 1. It's that. Ugh, yuck. It'd be right here. Okay. And then we're going to go 1, 2, 3. We're going to go 1.5. Oh my God. We're going to go up to here. And then going 2 to the right. I'm not going to go to the right. I'm going to go 1 to the right. There. That's a half. I think. I forgot something. And I drew it wrong. You get the point. Scale factor of 1. If it's a scale factor of 1, I mean, let's talk about this for a second. 5 times a half. 5 times 1. And then 5 times something bigger is 5 over 2. If you multiply anything by 1, guess what you get? You get that number you multiply by 1. 5. Nothing changes. So this one, if you multiply this guy, this picture, right, the side lengths by 1, guess what? You get the same exact picture. This, like this, like this, like this. You get except you have to be better at drawing than me. Like that. You get the same exactly. Nothing changes. But if you multiply by half, a number less than 1, guess what? It becomes smaller. Your 5 is now 2.5. It got smaller. If you multiply by something that's bigger than 1, 5 over 2, ladies and gentlemen, is the same thing as 2.5. Right, so that takes me what? 12.5. So this one over here is going to be 2.5 times as big. I'm not going to draw that. Try not to. 3. Let me draw it. So 1, 2, 3. And then this one is just one box, so it'd be 3 boxes. 1, 2, 3, something like this. That's going through 2, 2, 2, 2. All right. Don't go too crazy here. I wouldn't ask you to do that. Last one. Reverse it. Figure B is a scale copy of A. Okay, so we went this way. Find a scale factor. Okay, from A to B and then B to A. All right, so let's find a scale factor. Pick a sign. Let's pick this guy here. 1, 2, 3, 4, 5, 6. We need some numbers, so that's 6, and this is 1, 2. So 6 became a 2. Let's find the scale factor. So, and if you want to put a couple of numbers, so this one is 1, 2, 3, and now it's a 1. So 6 became 2, 3 became 1. Obviously, a scale factor is a reduction. So reduction is small over big. Let's use 6 and 2. 6 and 2, it'd be 2 over 3. Sorry, 2 over 6. And if you reduce that, it'd be 1/3. So everything here was multiplied by 1/3 to get to B. So going is times 1/3. What about if we went back? What's the reciprocal of 1/3? It would be times 3. Does that make sense? Because think about it. Look, 1 times 3 is 3. 2 times 3 is 3. So everything's getting bigger by a factor of 3. Okay, that's supposed to be a multiplication sign. All right, so the scale factor from A to B is 1/3, and the scale factor from B to A. And we talked about these two numbers, 1/3 and 3 are called reciprocals. Here, put a couple of numbers down. That's a 1, that's a 2, that's a 1, 2, that's a 2 over here, and this is a 3. What? I can't be right. Oh, I see. Ugh, that's a 1, that's a 2. This guy over here is 1.5. And this guy over here is 3. Yeah. Okay, so what's the scale factor? Well, it's kind of obvious, right? How did 1 become a 2 times 2? How did the 1.5 become a 3 times 2? Well, the scale factor going that way is times 2. The enlargement is times 2. What about going backwards? Going back from B to A, the original one. Right? So if you want to go to B and go to A, it would be a reduction. And what's the reciprocal of 2? It'd be 1/2. Okay. And then finally, well, same idea again. So put some numbers there. This is 1, 2, 3, 4, 5. This is a 2. This is a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's a 10, and that's a 4. Excuse me. Let's go this way. Find the scale factor. So let's use the number 10, the width here and the width here. So it's B. So first of all, it's a reduction. So small over big. If we use numbers 10, 4, it's going to be 4 over 10. Simplified becomes 2 over 5. So if I take 10, right, and multiply, if I take 10 and multiply that by 2 over 5, it's going to give me 4. If I take 5 and multiply that by 2 over 5, it's going to give me a 2. Okay, so it works. Now, what if I went the other way? What if I went this way? If I take, what's be the scale factor? Well, the scale factor is going to be the reciprocal of 2/5, well, which is 5 over 2. So if I take 2 and multiply that by 5 over 2, will I get 5? Well, I do, because 2 times 5 is 10. Then if you divide it by 2, you get 5. What if I take 10 and multiply that by 5 over 2? Well, sorry, not 10. If I take 4, right, because I'm going this way, what if I take 4 and multiply by 5 over 2, which is 2.5? Will I get 10? Well, 4 times 5 is 20, and then divided by 2 is 10. So notice that going this way, the enlargement, I have to multiply these numbers here by 5 over 2. Okay, and again, just to 5 over 2 and 2 over 5, what are they called? They're reciprocals, right? Is that it? Yes, that's it. Done. See ya.